While some anthropologists still prefer the view that early humans lived in a Garden of Eden, prehistoric Africa was pure nightmare fuel, where our ancestors were not only hunters, but also the hunted. According to anthropologist Raymond Dart, our forefathers differed from living apes in that they were killers, carnivorous creatures that seized living adversaries by violence, battered them to death, tore apart their broken bodies, dismembered them limb from limb, slaking their ravenous thirst with the hot blood of victims and greedily devouring livid, writhing flesh. The killer ape theory, also known as the killer ape hypothesis, proposes that war and interpersonal aggression drove human evolution. According to the theory, humans' ancestors were distinguished from other primate species by their greater aggressiveness. And this aggression lives on in humanity today. In fact, according to the killer ape theory, violence drove the evolution of bipedalism, motivating the evolution of the use of upper limbs to wield weapons. The theory differs on which type of violence served as the evolutionary catalyst, one-on-one aggression or group aggression. Furthermore, at the time the hypothesis was published, there was a lot of debate about whether early man hunted for food. Though widely accepted, the hypothesis that hunting behavior influenced the evolution of early man remained controversial. As late as the turn of the millennia, many anthropologists questioned the notion that hunting was common in our ancestors, arguing that early humans, including Neanderthals, were merely highly successful scavengers. According to some fossil experts, extreme violence is in our nature. The theory had fallen out of favor until recently, when scientists argued that our larger brains evolved primarily to help us cooperate with one another. We learned language and other skills that enabled us to maintain complex societies. Of course, some form of communication and cooperation is also required for group hunting, as seen in chimpanzee groups today. They were not using any long-range projectile weapons that we are aware of. The Homo erectus hunt was simple yet effective, fueling not only their larger brains, but also the increasing complexity of those early humans. The evidence suggests that hunting evolved much earlier than previously thought, and that it had a significant impact on human evolution. Early hominids had smaller teeth than Australopithecus, but their enamel was thick and their jaws were strong, indicating their teeth were still adapted to chewing hard foods. According to dental microwear studies, Homo habilis' diet was flexible and versatile, and they could eat a wide variety of foods, including some tougher foods like leaves, woody plants, and animal tissues, but they did not routinely eat meat. Some of the earliest cut and percussion-marked bones, dating back to 2.6 million years ago, provide additional evidence for Homo habilis' diet. Scientists typically associate traces of large animal butchery, as well as direct evidence of meat and marrow consumption, with the earliest appearance of the genus Homo, including Homo habilis. According to a study titled Prey Mortality Profiles indicate that early Pleistocene Homo at Olduvai was an ambush predator. At least 2 million years ago, ancient humans used advanced hunting techniques to ambush and kill antelopes, gazelles, wildebeest, and other large animals. The discovery delays the definitive date for the start of systematic human hunting by hundreds of thousands of years. Researchers compared the types of prey killed by lions and leopards today to the types of prey chosen by humans 2 million years ago, demonstrating that men and women could not have taken kill from other animals or eaten those who died of natural causes, but rather chose and killed what the prey wanted. In the study, researchers examined a massive butchery site in Tanzania's Olduvai Gorge. More than 1.8 million years ago, ancient humans, most likely Homo habilis members, brought the carcasses of wildebeest, antelopes and gazelles to the site, where the meat was then extracted from the animal's bones and consumed. But humans preferred older animals, while lions and leopards preferred mature adults. The findings for several species of large antelope, for example, revealed that humans preferred only adult animals in their prime. In contrast, lions and leopards killed the old, young, and adults alike. After our species developed a taste for meat, it was given a dense, protein-rich source of energy, and we no longer needed to invest internal resources in large digestive tracts to process more difficult-to-digest vegetation and fruit. Early humans most likely sat in trees, waiting for herds of antelopes or gazelles to pass below before spearing them at point-blank range. This skill, developed much earlier than expected, had far-reaching implications. For millions of years, as the hominid brain was developing, our ancestors were less the hunters and more the hunted. In our present epoch, the Holocene, the Earth is essentially humanity's playground. The Pleistocene was far more terrifying. Near the dawn of the Pleistocene, roughly 2.8 million years ago, a young child belonging to the early hominin species Australopithecus africanus was killed. The child's worn and scratched skull was discovered in 1924, along with the mangled bones of other small to medium-sized animals. Archaeologists dubbed the skeleton Taung child. Today, the best explanation for the skull and the accompanying collection of skeletons is that they were gathered by an ancient, large bird of prey, the leftovers of many, many meals. This realization evokes a nightmare scenario. After being plucked from the ground and carried off into the sky, this was where the young Australopithecus child was eaten. Ever since the fossilized skull of a hominid was found at Taung, on the edge of the Kalahari Desert in 1924, scientists have wondered what the child was doing there and how it died. Despite exhaustive excavations, no other specimen of Australopithecus africanus, as the fossil was named, has ever been found at Taung to indicate that this was a regular hominid haunt. Nor does the evidence suggest that a carnivore such as a leopard carried off the child. A large bird of prey, such as an eagle, may have killed the child on the nearby plains and carried it off to its nest. In fact, the Taung child fell from the sky. The theory explains why precious few fossils of large antelopes have been found at the Taung site, which you would expect if big cats had been responsible. This sets the site apart from other cave sites where hominid fossils have been found. The fossils at Taung are mainly the small skulls of baboons and hyraxes, fragments of tortoise carapaces, and the shells of large birds' eggs. Bones from modern eagle nests commonly show depression fractures in the top and sides of the skulls, and V-shaped cuts made by the beak. The base of the skull has usually been torn away by the bird as it tries to get at the meat of the brain. All of these features are found repeatedly in the fossil bones of Taung. The child's skull may have tumbled from a nest in an overhanging tree and rolled into the cave where it was found. As adults, our ancestors probably didn't have to worry too much about winged predators, but the ground presented its own set of horrors. One concern was ancient crocodiles, which launched ambush attacks from bodies of water. An individual of the species Homo habilis, dubbed OH8, may have fallen victim to such an attack 1.8 million years ago in what is now Tanzania. Leopards, which hunt baboons, monkeys, chimps, and occasionally gorillas, were more dangerous than crocodiles or birds. The cranium of a Paranthropus robustus, an early hominin discovered in South Africa, provides direct evidence that leopards hunted our ancestors over the last 3 million years. In another example of pure nightmare fuel, an early hominin versus baboon deathmatch ended in a draw when they fell down a hole. Was it a fight to the death? An ancient hominin known as Littlefoot, who lived in what is now South Africa 3.67 million years ago, may have died in a battle for food with a large male baboon-like monkey after falling down a hole. Australopithecus prometheus, a distinct species of hominid that was named based on other fossils, may have been an ancestor to a group of heavily built hominins known as Paranthropus, which lived alongside early members of our human genus. Littlefoot's features, including her flat face, suggest that Australopithecus prometheus could have been a member of this group. Excavators discovered a skull belonging to an extinct baboon-like monkey species beneath Littlefoot's pelvis while excavating her skeleton, which is over 90% complete and took 14 years to excavate due to its fragility. They discovered a shin bone beneath Littlefoot's right arm, 2 baboon vertebrae intermixed with the bones in Littlefoot's spine, and a baboon arm bone next to Littlefoot's left thigh bone. It's likely that all of the bones belonged to the same individual, a male that was at least as large, if not larger, than a modern male baboon. This raises a nightmarish possibility that the two fought before falling to their deaths. The cave where Littlefoot and the ancient baboon-like monkey were discovered must have been difficult to access 3.67 million years ago, because Littlefoot's skeleton shows no signs of being disturbed by scavengers. The cave most likely opened out to the surface through a steep shaft and was difficult to get in or out of. We know that fig and other fruit trees grow around the entrances of such caves today, and they must have done so in prehistory as well, making the area appealing to fruit-eating primates like hominids. So it's possible that Littlefoot had a violent confrontation with the male monkey above the cave entrance. She could have been looking for food in the trees and got into a fight with the large baboon. Both individuals may have lost their footing during the fight and fallen down the cave shaft, dying in the fall. This would explain why the bones of the two became intermingled, implying that they fell into the cave at the same time before being buried and fossilized. It's possible that Littlefoot was killed by a hyena, a saber-toothed cat, or a leopard, as there was a leopard lower jaw with the skeleton. She could also have died after being bitten by a poisonous snake, which can still be found nearby. This would not be the first time that researchers have argued that a famous ancient hominin met a violent end. Dramatic and violent death from African predators must have been a constant risk, as the landscape had a much greater variety of large carnivores than we do today. And with that tantalizing statement, we leave you to ponder the mysteries of our shared human history. Until next time, stay curious and stay questioning. Also, please subscribe, share and explore our channel's other highly compelling videos. Thank you and take care.